Hello, good morning everybody. I am Mohinder Kumar, lecturer civil engineering from Government Polytechnic College, Batala. Today we have a very good topic from the subject of survey 1 of third semester civil engineering, and we will discuss today on the topic of auto level and also some problems of leveling such as errors in leveling, mistakes in leveling and different types of leveling. So, these topic will be the part of my topic today's lecture. So, let us study about the subject of surveying, in which today's topic is auto level. It is well known that for the measurement of distances, bearings, horizontal and vertical angles, finding areas and volumes from contour maps etc., number of surveying instruments are used such as chains, tapes, compass, theodolites, levels, plane tables and planimeters etc. So, these are all instruments you have been conversant with some of these instruments. On account of developments in technology, more electronic instruments have been developed for increasing the speed of the work for accurate information of the area to be surveyed. These instruments not only save time and energy, but also have proved to be economical. One of the several modern surveying instruments, we will discuss today the instrument of auto level. So, this is new instruments and is known as auto level. Auto level is used to measure the vertical distance of a object of a point relative to horizontal line of sight provided by the instrument. It is also called as adjusting or self leveling level or pendulum level and auto set level. So, these are the few names by which an auto level is known, such as self leveling level, pendulum level and auto set level. So, these are the names by which an auto level is known. So, auto level is similar to the dumpy level. You must have gone through this dumpy level, you have studied, you have done practicals on dumpy level. So, auto level is just similar to that with its telescope fixed to the tribreach. This level does not use the conventional tubular spirit level, but instead it uses circular spirit level for approximate leveling in order to set the inclination of the line of sight with the horizontal. So, within the permissible limits. So, this is the one of the major difference, that it does not use the tabular spirit level which we find on the dumpy level, but instead an auto level uses circular bubble spirit level for approximate leveling in order to set the inclination of the line of sight with the horizontal within the permissible limits. So, this is the major difference between the level tube of dumpy level and an auto level. Auto level is also designated as self aligning level. It is also known as self aligning level. In this type of level, the line of sight is no longer leveled manually by a tubular spirit level, but is leveled automatically. This has been discussed in the previous slide, that is, in this type of level the line of sight is no longer leveled by a person, that is manually by a tubular spirit level, but is leveled automatically, that is leveling is done automatically within a certain tilt range. This is achieved by an inclination compensating device. So, this is to be noted, within a certain tilt range, this is achieved by an inclination compensating device and which is known as tilt compensator. It is suspended like a pendulum and inserted in the path of a light rays through the telescope, and that is why it is sometimes called as pendulum level also. An auto level is sometimes also called as pendulum level. Auto level is, so we will study a few advantages of auto level over the other conventional levels. Auto level is of recent development, that it has been developed in the recent times and has some following advantages over the other levels such as Dumpy level, Cushing's level, Y level, etc. IOP level is there. So, auto level has some advantages over the other conventional levels. So, which are those? First one is high precision, mean elevation error or inward staff graduated to 5 mm divisions. You must have gone through the staff, you must have seen in the practical classes. So, mean elevation error or inward staff graduated to 5 mm divisions varies between plus minus 0.5 to 0.8 kilometer of forward and backward leveling. That is, we can achieve the desired accuracy or precision with the use of an auto level. This is one of the main advantages of auto level. Second is high speed. Leveling work can be done quickly by using auto level. That is, we can achieve the desired speed by using auto level. The time taken for leveling work is about 50% of that required with the ordinary level. It is very useful where the work is to be carried out in limited time. That is, time wise an auto level is of much use. That is, we can save much time by using an auto level. Third is comfortable. It does not require any protection from the sun as is done in the conventional levels. There are sun shades are there with the that has been that is given with the instrument. So, we do not require any protection from the sun when we use auto level. The control of level, which is so tiring to eyes, nerves and hand, is all these difficulties are eliminated in the auto level. So, we feel much comfortable by using an auto level. Fourth one is freedom from errors. Errors due to settlement are eliminated in auto level. There is no possibility of forgetting to get the bubble in the center. Next is freedom from errors. The erect telescope image, the leveling rods and the erect figures in proper sequence reduce the chances of committing the errors. You must have seen in the readings, when we take readings with the formal staff, we find that we see the reverse image of the object by seeing through the telescope. We find the inverted image, but in the auto level we always find the erect telescope image. So, the leveling rods and other erect figures in proper sequence, which reduce the chances of committing the errors, that is, errors are reduced. Next is freedom from external influences. Which are those influences? The external influences like rain, wind, sun, loss of light due to cloud, that is, when clouds are there we find much less quality of light, marshy ground, magnetic fields, vibration, etc., have no influence on the leveling work. When we use an auto level, we do not find such difficulties, or there is no less light, we do not have to worry for all these things, that is rain, wind, sun, loss of light due to cloud, marshy ground, magnetic field, vibration, etc. They have no influence on the leveling work when we use the auto level. And last is range of application. So, it is used, an auto level is used on medium and large sized projects, that we can use the auto level from medium projects to large sized projects. Different type of self aligning levels are in use nowadays. That is, we find a variety of auto levels. So, we can choose the auto level according to our requirement, our type of projects, etc. So, these are some of the other advantages, or we can sum it in such a way that survey work can be done very fast when we use an auto level, and less chances of error we have just studied. By using the auto level, there are much less chances of committing the error. So, magnification available is more, that is, we can see the object more clearly, more magnified image of the object is seen by using auto level. So, range is more. Next is image is erect, we do not find inverted image. When we see through the auto level, we always find the erect image. So, less chances of errors are there. So, this is the detail of the technology used in the auto level. For accurate leveling, a compensator, as already have been discussed, that is, this is a major component. A compensator is used, you see on your monitor screen. A compensator is used in level in order to set the inclined ray to pass through the center of the crosshairs, through which the horizontal line of sight passes, as is clear from the following sketch. Please see on your monitor screen. So, a compensator is being shown, how it changes the figure or the image. So, compensator is used in the leveling in order to set the inclined ray to pass through the center of the crosshairs, through which the horizontal line sight passes, as is clear from the following figure. How a compensator is used in an auto level. So, these are optical schemes for level compensating. First one is line of sight is horizontal, and figure second is line of sight inclined. Third one is scheme number 1, fourth one scheme number 2, and we will study about these two schemes in the following slides. So, these are some of the schemes for level compensating, and this is the fifth one scheme. So, in figure 1, line of sight CF is horizontal, and the staff reading is taken and read on the center of the crosshairs at F on the focal planes, whereas in figure 2. So, please see on your monitor screen in the figures. Figure first one figure, the line of sight CF is horizontal and the staff reading is taken and read on the center of the crosshairs at point F on the focal plane, whereas in figure 2 on your monitor screen, when the line of sight is inclined, the line of sight C1 through the telescope is inclined at a small angle alpha. Alpha is less than 15 minutes with the horizontal CF. You please see on your monitor screen, the line of sight C1 through the telescope is inclined at a small angle alpha, and alpha is less than 15 minutes with the horizontal CF. So, now in the scheme number 1, EF1 is turned to orient along EF. You see on your screen, scheme number 1, EF1 is turned to orient along EF, and in scheme number 2, in figure 4 on your monitor screen, EF1 is turned to orient along EF, and in scheme number 3 on your monitor screen, the image of F is transferred on to F1 by successive reflections. These are the schemes. So, the optical compensator maintains a level line of sight even through the instrument is lifted as much as 15 minutes arc. The instrument is level by using a 3-foot screw which we find on the level. So, this is the arrangement being provided on the level. The instrument is leveled by using a 3-foot screw arrangement in which in conjunction with a small circular level which is provided on the level. The compensators a prismatic device. So, a compensator is a prismatic device which is subjected on fine non-magnetic wires and may be free suspension compensators or a mechanical compensator. In the first case, that is free suspension compensator, consists of the two prisms on a suspended mount within the telescope tube placed in the optical path between the eye piece and the objective. If the level is lifted, this system hangs like a plumb bob and keeps the horizontal line of sight on the crosshairs automatically. It utilizes the action of gravity in the operation as it causes the optical system to swing into position which provides a horizontal line of sight. In order to check the working of the compensator, slightly move one of the foot screw, and if now the reading of the staff remains constant, then it means that the compensator is working. Once again, in order to check the working of the compensator, slightly move one of the foot screws which we have on the level, and if now the reading of the staff remains constant, then it means that the compensator is working. In the latter case, that is mechanical compensator, the compensator consists of a fixed roof prism above two swinging prisms which are supported on 4 metallic tapes, thus forming a cross spring flexor pivot. In both the cases, the compensator is attached to the prism moving in a closed cylinder which reduces the oscillations of the lightweight compensator. The advantage of wild Na2 auto levels which is being used and manufactured by Nikon is that when the circular bubble is at the center, the line of sight is horizontal for all pointings of the telescope. The speed of the work is increased with accuracy. When we have accuracy, the speed of the work is increased automatically. The stability of the line of sight is ensured from the influence of strong winds and traffic vibration. In auto levels, wild Na2 and NAK2, just below the eyepiece, a press button is provided for compensator control. So, you see on your monitor screen an auto level is shown and its trade name is NAK2 and it is manufactured by Nikon, Japan. When the button is pressed, it tends to maintain the horizontal line of sight. So, following figure shows auto level AP7 and NAK2 manufactured by Nikon Corporation, Japan. So, these auto levels are now being manufactured in India also, but formerly they were manufactured in Japan and other foreign countries. So, these are the figures of Nikon NAK2 on AP7 by Nikon. So, on your monitor screen, this is the image of the auto level AP7 which is manufactured by Nikon Corporation, Japan. So, nowadays these instruments have been manufactured by India also, and formerly they were imported from other countries. So, now we move to the second topic of this lecture, which is errors in labeling and how we prevent errors in labeling and their prevention. The following are the main sources of errors in labeling. What are those? First one is instrumental errors. Next is errors of manipulation, errors due to settlement of label and staff, errors due to natural causes, common mistakes in labeling. These are few errors which we will study one by one. So, first one is instrumental errors. When we use the instruments, the errors are to come. So, how we are to prevent these errors? So, first one is instrument error, and in which the very first one is imperfect adjustment. The essential requirement in labeling is that the line of collimation must be horizontal when the instrument is labeled. This is the principle of the labeling, that is, the line of sight must be horizontal when the instrument is labeled, and we have to furnish a horizontal line of sight. If the label is in perfect adjustment, the line of collimation is parallel to the bubble axis, so that it becomes horizontal when the bubble is centered. If the adjustment is not correct, the line of collimation will be inclined, and even though the bubble is central. So, the error due to inclination of the line of collimation is proportional to the distance of the staff from the instrument. This is most common and serious source of error. It can be eliminated. How we can eliminate this error of imperfect adjustment? First one is by testing and adjusting the instrument, and second by equalizing the back sight and foresight distance. That is, we will keep equal the distance of back sight and foresight. Second is defective label tube. If the bubble is sluggish, that is, it does not move rapidly, it may remain in center even though the bubble axis is not horizontal. And if it is oversensitive, much time is wasted in labeling the instrument. So, you must have experienced such difficulties while using a label. So, it can be sluggish, it can be oversensitive. So, we find such problem in the labeling of the instrument. Therefore, the label tube fitted with the label should be only of the required sensitiveness, that is, it should neither be more sluggish nor oversensitive. So, the level of the label tube of the fitted with the label should be only of the required sensitiveness. Third one is shaky tripod. A shaky tripod renders the instrument unstable and thus leads to erroneous readings. That is, the tripod stand should not move. So, we should tighten the screws of the tripod. The tripod should therefore be examined and loose joint should be tightened before doing the project work. So, before doing any labeling, we should check all the loose joints and all those should be tightened. Next is incorrect graduations of the staff, that is, which are the readings inscribed on the staff. If they are incorrect, so this is the error. When the staff is new one, the graduations should be checked up with an inward or inward tape, as there is every possibility of error in graduating the staff. That is, the labor which prepare the staff, there can be error in graduating the staff. It is, however, negligible in ordinary work. So, that is, if the work is of ordinary nature, then we can neglect this work. Next is Second is errors of manipulation, careless leveling up of the instrument. The instrument should be accurately leveled and the hand should not rest on the telescope or tripod. So, we have got such a nature that we keep our hand on either on tripod or on telescope. So, we should not be there. So, the instrument should be accurately leveled and the hand should not rest on the telescope or tripod while taking reading. So, this is a very bad habit and we should all avoid it, that we should not keep our hands on either on the tripod or on the telescope. So, that is which can cause errors in our leveling. Next is the bubble not being central at the time of taking readings. This is the most serious and common source of error. The position of bubble should be checked just before and after each reading is taken. That is, we should check the leveling tube before and after the taking the reading. Before and after each reading, we should check whether the bubble is in center or not. The bubble should be brought in the center of its run if necessary by means of a leveling screw most nearly in line with the telescope. That is, a leveling screw is provided. So, we can keep the bubble in the center by using that screw, that is, the bubble should be in the center. So, next is the parallax not removed. You must have studied about parallax, that is the movement of the picture with the image. So, the error is due to imperfect focusing of the eyepiece. When we move our eyepiece, the movement of picture should not be over there. So, this error is due to the imperfect focusing of the eyepiece and of the object glass. The parallax should be entirely eliminated by proper focusing before taking any reading. So, parallax should be eliminated by proper focusing, that is, focusing should be done properly by using focusing screw before taking any reading. Next is the staff not being held vertical. So, the person who is holding the staff, he should hold the staff very vertical. If the staff is not held perfectly vertical, the reading obtained will always be too great. That is, if the staff is not held vertical, the reading which we get from the staff will always be too great. This error is much pronounced for greater readings of staff. The greater the staff readings, greater is the error. So, great care should be taken when taking larger reading, that is, when we are taking larger readings, great care should be taken. This error can be avoided. How we can avoid it? By keeping the staff vertical, by having a spirit level or a pendulum plumb bob attached to the staff, or by waving the staff and noting the smallest reading. So, these are the few things which we can do, that is, by keeping the staff vertical, by having a spirit level or a pendulum plumb bob attached to the staff, or by waving the staff and noting the smallest reading. Next is settlement of level in the errors due to settlement of level and staff. If the level settles or the staff settle, first we study settlement of level. If the level is set up on soft ground, that is, the ground soil is very loose, it may gradually settle down in the interval between taking a backside and the next foresight reading. It will make the foresight reading smaller than it should be. The level should therefore be. So, how we can avoid it? The level should therefore be set up as far as possible on the solid ground. That is, before setting the level on the ground, we should check the ground that it should be solid. So, the level should therefore be set up as far as possible on solid ground and the legs of the tripod firmly pressed into the ground. that is the legs of the tripod which have iron shoes at the bottom should firmly be pressed into the ground to avoid this error. Also, the foresight reading should be taken as soon after taking the backside reading, that is foresight reading should be taken as soon as taking the backside reading as